Welcome to What's Your Signal, the podcast exploring modern ways to connect people, places, and things everywhere. You're joined by me, Taylor Walker, and my co-host, Mauricio Stefan. Hey, Mauricio.
Hi, Taylor. How's it hanging?
Oh, good. So, Mauricio, how would you describe SD-WAN to an 83-year-old grandmother?
Well, I'm not sure that my 83-year-old grandmother would care what SD-WAN is, but if I was describing it in layman's terms, I would say it's the ability to leverage, multiple internet links in order to ensure that your applications stay usable without having kind of that drop in that application as you fail over between links. So it's the ability to kind of steer those across links dynamically without interruption.
Okay.
Which was not very layman, but
Yeah,
it is
like,
what
your
it is.
grandmother's very advanced. So,
Well, like I said, my grandmother's not going to care. So,
well, SD-WAN is also infamous for its traffic steering capabilities, and often, at least in the past, it was really compared to like an interstate with passing lanes and off ramps and various traffic flows, so you could keep moving towards your destination, but maybe getting there different ways. So, getting data from point A to point B with something like a GPS, but just like how our highways and our interstates are always under construction or our GPS is maybe not always working, SD-WAN technology also has to really evolve and expand to meet modern needs. And today we're really discussing how modern SD-WAN solutions complement things like cellular and SASE architectures, which we've talked a lot about on the podcast before, to ultimately improve performance and secure today's networks. And joining us to help understand this topic is Head of Ericsson Enterprise Wireless Solutions Marketing and Communications, Donna Johnson. Okay, so Donna, can you start by giving us a little overview of SD-WAN history? Like, maybe why was it initially developed? Like, where did it come from? Was it solving certain problems?
Sure, and I've actually heard different dates for when SD-WAN started. Sometimes I think it depends on when your favorite company was founded, and that's when you decided SD-WAN actually started. But it's a fairly old technology at this point, at least close to 12 years old, maybe even a little bit longer. And it absolutely had an initial use case. It was a pretty clear-cut one, which was that MPLS costs too much, and companies needed a less expensive way of getting connectivity. And so broadband was sitting right there. And even 12 years ago, broadband performance was very high. So how could they take advantage of broadband and cut their costs for MPLS without sacrificing reliability? That was, it was marketing was much easier in those days, I would say, because the use case was really clear. The cost value of it was very clear. It didn't take off. It took a while, as many new technologies did. But a lot of companies really saw value in that, particularly those that had international MPLS links because they were so expensive.
And did it stay kind of the same for a while? Was it doing much evolving up to even a couple of years ago?
Yeah, very much. And so I emphasize that was the original use case because I think it was clear and had value. But nothing ever stops. And so it did absolutely continue to evolve. For example, in the first iterations of SD-WAN, it was an overlay technology. So it would sit on the side of the router, but the router would still be there and traffic would just go through it. So one of the first sort of big, I would say, technology steps was it became the edge router and ceased to be an overlay technology. So once it became the router, it had to take on a lot more responsibilities, including integration with other routing technologies, things like DMVPN and BGP. So SD-WAN itself became more complicated. And then another sort of leap, I would say, that occurred was it started to take on more and more of the security responsibility. So it made sense. The traffic now is all going through the SD-WAN appliance. It's building a secure tunnel. And even from the beginning, the SD-WAN tunnel was always intended to be secure and encrypted. But it just took on more and more of the aspects of a firewall, for example. And so, again, I think SD-WAN itself became more complicated. to some extent, the deployment of it became more complicated as a result. Integrating SD-WAN with your overall, now both WAN, routing, and security infrastructure became more difficult. But it was also simpler in the sense that now you had one vendor and one appliance doing it. And then I would say one of the last sort of big leaps, maybe, that SD-WAN technology took was moving from just being an edge to sort of data center technology to becoming an edge to cloud technology and taking on more and more responsibility over the cloud and the performance of accessing the cloud and even the performance of cloud to cloud with traffic that traversed the overall internet. So again, more responsibility on the SD-WAN solution. So yes, it's definitely evolved. Marketing it has become much more complicated. The number of competitors or companies involved in it have become much larger. The diversity of the solutions have become much larger.
Now, was the application persistence, has that been part of SD-WAN since the beginning with things like forward error correction and those technologies?
Absolutely. Even if it wasn't necessarily considered a layer 7 technology at sometimes, with that application awareness, application persistence, both quality and resilience, I think were really very fundamental to that initial use case. I know early on that ability to continue to have an application run under potentially a broadband link that had unpredictable performance characteristics was a really big part of the use case. And then having an application continue to run even if you switched the link. So initially, maybe from broadband to MPLS, of course, with our product moving from broadband to cellular or cellular to cellular. That ability to preserve the application consistency and performance has always been really important.
So we've had all these different iterations of SD-WAN, and what would you say are the key features of the SD-WAN solutions that we see today? I've seen it referred to as SD-WAN 2.0. What does that mean, or what's built into that?
Yeah, I maybe differ a little, because what I would say is SD-WAN, by becoming so broad in the way that we just talked about, and by so many different companies coming in, and by solving so many different use cases, I'm going to be controversial here. I think SD-WAN as a term has lost a lot of its meaning. When you have something like 65 different companies providing it, there is no way to say that it is any single thing. I think different companies have put different interpretations on it. They've emphasized different capabilities. It has really become synonymous in a lot of ways with that edge appliance and increasingly cloud appliance. Because it now does so much, it's effectively replaced the role of sort of the traditional, let's call it edge router, firewall, VPN termination point, and it's really become all of those things. So because of that, I think it's hard to classify it in a clear way. And I think, and I take responsibility for some of this because I've been working in this technology now for over 10 years. I think we have confused the market in some ways about SD-WAN because we've associated so many different capabilities with it and so many different products. I don't know that we can put our finger on what it is anymore.
Yeah, speaking of that confusion, Donna, there's a lot of other acronyms that I hear around SD-WAN, like SSE and SASE, and how do those things start to relate? You talk about SD-WAN expanding. Are those expansions of SD-WAN, or are those something completely different?
I think in some cases they are. Do you remember SD branch, Mauricio, when that was a thing? Do you remember software-defined everything?
Software defined everything.
Yes,
That's
yes. I
right.
think we're still trying to achieve that goal. But yeah, I think things like SSE are really a reinterpretation of that edge role of SD-WAN, with an emphasis on security. But most SD-WAN solutions today really have that security built in. Now, you could say that, well, the SSE device is really technically about connecting to the cloud for security. But again, I think we've over time redefined SSE as well. I think SASE was an attempt to unify what we're seeing as this convergence of SD-WAN and security. So as I mentioned, the SD-WAN appliance has taken on more and more of the security role. then connecting to the cloud, where a lot of the security capabilities have been in the cloud, sort of for this different growth vector, which is cloud delivered security. And we're seeing in a lot of enterprises, the buyer for that become the same person or the same team. So SASE was a view of how do we unify not just the vision, but the technology so that someone could feel like they had a comprehensive solution from edge to cloud that wasn't composed of a lot of different vendors trying to cobble things together. So they're not synonyms of one another. I think they are attempts to sort of re-rationalize some of the technology that's been embedded in SD-WAN and put it in a larger context.
Today's SD-WAN solutions, I mean, I feel like if you're smart as an enterprise, you can't really invest in one that isn't optimized for cellular. And you'd probably be hard pressed to even find one that's not optimized for cellular. Maybe I'm wrong in
Oh,
that.
you would absolutely have a hard time finding one that's not
Okay.
optimized for cellular.
um,
In fact, there are very few companies that have sort of taken cellular as a primary and legitimate, let's say, network connection.
I guess I say that because I'm curious about how does SD-WAN impact some of the 5G network capabilities that are kind of buzzwords right now, like network slicing? Do those work together? Are they mutually exclusive? Are there 5G features that kind of only work best with the right SD-WAN solution?
100%. So cellular was a part of SD-WAN solutions even early on, particularly in some remote locations. But I would say that 5G has really accelerated that. So in the past, you could use 3G and it was fine for some lightweight applications, or you could do bonding 3G links together. But it's really only with the advent of 5G that I think true cellular as a primary link or on equal weight to a broadband link was really available. And cellular came with its own technology issues that you had to overcome. You had to be intelligent about the use of it. You couldn't just treat it as another link. Even the way that you measure latency and loss across that link, the way that you did failover, had to be somewhat tailored to and unique to the cellular link. And certainly, even today, being cognizant of the data usage and how much data is going across it, so therefore how often you probe it, and under what circumstances you use it, have to be very sensitive to the fact that it's a cellular link. And I think that we've, not to toot our own horn, but I think that we've been at the forefront of that because we are a cellular first company, and we do have most of our customers using cellular links in their SD-WAN networks. But you mentioned slicing. You threw a whole bunch of new acronyms at me that I have to remember. But definitely slicing is an evolution of 5G that we think is going to be really, really important. So I'm going to harken back. I mentioned in the very beginning that MPLS was one of the original use cases. One of the benefits that MPLS had was you could establish queues. So you could work with your service provider and you could associate certain types of traffic or tag certain types of traffic for different MPLS queues. And because of that, you could have some element of predictability or even prioritization and improved performance for certain applications. And slicing allows us in some ways to recreate that. I would argue probably even in a better way, but it lets us take certain applications and put them on certain slices that is suited to that traffic. So maybe it's an application that needs particularly low latency, or one that's low bandwidth best effort, such as IoT traffic, or even large bulk transfer where you don't want to pay the highest 5G rates. You just need to eventually get the file over. Those different application characteristics now can be satisfied by different slices. But the trouble with MPLS was, how do you associate an application with a queue? And there were different ways to do it. You could build it in from your service provider, you could tag the traffic, then you had to go back to the application and set up the tagging correctly. It was tricky and it was complicated. SD-WAN simplified the association of application traffic with MPLS queues. And I think we're trying to do the same thing with 5G. Is we're trying to make it very clear, simple, and intelligent how you associate an application with a 5G slice, so that you can get the behavior that you want. You can optimize the cost, the carriers like it because it lets them save the high performance part of their network for the applications that most need it. So it lets them optimize their allocation of spectrum and connections as well. But that association of application to slice is something that we're continuing to evolve on, and we think is a really important part of making 5G again kind of accepted as a primary link within your WAN.
One of the things that I was curious about is so originally SD-WAN was really associated with sites, right? And just like physical locations. But now obviously we know that vehicles are connected. Is there a difference in the functionality of SD-WAN when we're comparing sites to vehicles? Does it work better in one than the other? Are there what should we know about those differences?
So 100%. So you're absolutely right. First iterations of SD-WAN only looked at fixed sites, which makes sense because the first iterations of SD-WAN were really focused around the use of MPLS and broadband. And no one's ever tried to trail a broadband cable behind their vehicle. If
Ever?
they did, it probably didn't work that well. So vehicle SD-WAN really only becomes possible when you have cellular connectivity in the vehicle. And SD-WAN, while it can be used with one link, is almost always associated with two or more links. So to use it in a vehicle, you have to have, you ideally have to have two modem connections to two different cellular links, or even cellular and satellite, to really get the benefit of SD-WAN. But it has taken off. I mean, in our customer base, we've seen it used. We've seen really the pace of vehicle SD-WAN growth outpace that of fixed sites. But you asked, is there differences? And the answer is 100%. So when you're in a fixed location, you can kind of assume that the characteristics of the link are going to be relatively static. A broadband link, a cable link might vacillate, but generally it's a pretty static and known link. And you generally only have to move traffic if there's some significant event. Obviously, if a link goes down, there's some backbone issue maybe that affects the performance on certain carriers. But in general, the network is relatively static. In SD-WAN from a vehicle, the network is incredibly dynamic because by its nature, a vehicle is often moving. And when they move, they're moving in and out of different carriers' networks. The characteristics of their signal is varying the entire time they're driving. So there's a lot, and cellular in and of itself is somewhat less predictable than wired performance. So the unpredictability of the network becomes very high. Therefore, the need for SD-WAN to compensate for that unpredictability and to maintain high application performance and quality even throughout that can be even more complicated. So you have to have a pretty high level of cellular intelligence to be able to do that. You have to know the application characteristics you're looking for, what different cellular signal data means towards application performance, how you can adapt for that. You have to be able to fail fast between carriers. And, we like to do it because we can both, hop and juggle at the same time. We want to be able to do that even while understanding the cost characteristics of the different networks. And how do we sort of juggle the cost characteristics and hop between links to give them the best performance? So it is complicated in a vehicle. But if I could add on to it, I think SD-WAN is so important in a vehicle because, we're not talking here about being able to listen to Spotify while you drive across the desert. What we're talking about here is being able to support first responders, potentially, critical infrastructure as in vehicles. So, for example, police departments have really pioneered this, the ability for them to maintain high signal quality and application reliance, even as they move into remote areas, and the importance of them being able to always hold a connection so they can do things like upload video, alert the command center if there's issues going on. For them, losing a signal isn't an option. Losing application accessibility could be fatal. So we think that SD-WAN is some ways even more important in a vehicle. And I could tell you, dozens of use cases where it can be a matter of, life and death. I don't want to be too melodramatic about it. But it is really important both to the safety of people and to those first responders. So we're really excited with the work we're doing in SD-WAN inside of vehicles and the use cases that we found inside of our customer base.
Donna, I think, even those first responder use cases, those are extremely important. But even for, commercial enterprises, the vehicle is essentially become an office or a storefront on wheels, right? And I'm talking more than just food trucks, right? I'm talking about, repair fleets or even city public works fleets. Essentially those people are just working in their vehicle, and it has just become an office on wheels. And so even those applications require that persistence, because while it's not, life and death or public safety like it is for those guys, for businesses, it is critical. I mean, if we, especially here, if the internet goes down in our offices, we lose connectivity to all the cloud applications that make our business run. So, it's not just the people that make the business run; it is that connection to those applications. So, I think you're right. Is absolutely, even in those public safety use cases, it's still critical for the businesses to have that connectivity in those fleet vehicles.
That's fair. And I should caveat that by saying my daughter does think Spotify access while driving is like that. So, but no, you're 100% right. And I think something that people don't always know is that in a natural disaster, often the first network infrastructure to come back is the cellular infrastructure. Carriers are able to bring in, what do they call them, Mauricio? Goats? Cows.
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 And Colts. Colts might be the other one you were thinking of.
We're going to throw some acronyms out there that nobody will recognize, including ones I just made up. For all I know, GOAT is a real thing. But they
Simone
often bring
Biles.
back cellular almost before any other type of connectivity. So you're right. I mean, insurance adjusters, charitable organizations, all kinds of things take their vehicles out there. They set up mobile command centers. They start taking advantage of satellite connections that still exist, bringing in cellular. And so again, for them, SD-WAN is really important to be able to take maximum advantage of whatever connectivity they can find.
It has been cool to see. You just mentioned, satellite connections. That's another connection that can run through that infrastructure, and we've talked a little bit about that on the podcast as well. But like for vehicles, even how that can serve as a link, which is just improves the resiliency for those networks.
Yeah, we're seeing in places like Australia, for example, Starlink and other types of satellite networks have become very popular because while we love 5G, and I think I can say that, speak for all of us, we know that 5G is not going to cover the Australian outback anytime soon. And please don't let Telstra sue me for that. But realistically, there always are going to be areas where it's going to be hard to get particularly high performance signals. And so satellite fills a really interesting niche in that. And I think it's important that we enable and embrace the ability to add a satellite into your SD-WAN mix to kind of create that resilient connection. And I would say, we talked about SD-WAN, and one of the characteristics that many solutions have, including ours, is that ability to bond together links. So if a satellite link has low bandwidth, maybe if you put two of them together, you could get higher bandwidth. Or if you could put, a 3G signal even together with the satellite. If you start building a few of these, you end up with a pretty nice throughput, but you've got to have an SD-WAN solution to allow you to manage the traffic across that bonded link.
Yeah, speaking of kind of the things that we don't like to admit that cellular doesn't do well, right? A lot of enterprise applications require high upload throughput, and one of the current characteristics of cellular networks is they tend to put an emphasis more on download. So in order to get that high upload bandwidth that you need from cellular links, you do have to aggregate multiple cellular links together to get that high bandwidth for uploading. Like you mentioned, the videos from first responders, right? To get that situational awareness that they need in the command center, they have to have that upload throughput to get the videos out of the vehicle.
Yeah, 100%. And that's a really good point. And I mean, if only we knew someone who built out cellular infrastructure to help emphasize that upload use case. That would be really handy.
And on the topic of bonding, I think link bonding, correct me if I'm wrong, but link bonding used to primarily be referred to as this bandwidth aggregation, like what you guys are referencing. But today there's kind of different iterations of bonding, right? Like flow duplication and flow balancing fall under that same umbrella. And are those solutions that are facilitated through an SD-WAN infrastructure as well?
Definitely. And you raise a good point. I mean, to me, bonding, which is not my favorite marketing word. I feel like we could come up with something better. But it's all about treating all of your capacity to some extent as if it were one link, and then allowing your SD-WAN solution to just be really intelligent in how it uses that. So maybe it is duplication, which is a really nice way to ensure that no packets are dropped, because if one link goes down, it's okay. The traffic has already been sent on an alternate link. It allows you to fail over quickly because you've already got this other link in use. It allows you, as Mauricio was saying, to bond them together to get better throughput for things like upload. So it's really just about that sophisticated understanding of all of your connectivity. Like you've got it all at your fingertips. How are you going to use it intelligently? And that's really where SD-WAN comes in.
Donna, you've mentioned the word simple a few times, and simplicity and simple solutions, which I think is what most enterprises are looking for today because they have a lot on their plate. But at the same time, they're hearing things like you also need a zero trust architecture and you also need SASE. And is there a world where things like zero trust and SASE and SD-WAN all live together? And is that the best way to do it? Or are these things that should just be kind of like a la carte based on what you need?
Yeah. Well, if you could remember back to 30 minutes ago when we started this conversation, I talked about all of the additional capabilities that are getting built into SD-WAN, and I think for a while it was an alphabet soup. We're just going to throw another technology in, and many vendors grew through acquisition. So if they needed a firewall, they bought a firewall. And if they needed cloud security, they bought cloud security. And so you ended up with these solutions that purported to do everything, but they weren't always well integrated with one another. And that had two major problems. One is there were all kinds of gaps and inconsistencies in it that take time to work out. But the other is that the configuration of those and the troubleshooting became very, very complicated, because you were talking about different motifs and different ways of understanding the network, even different ways of tagging applications and users and links. And so I think SD-WAN for a while almost got bogged down under its own weight, and configuration became very difficult. I would say the next wave of SD-WAN, and many companies, including ourselves, are working on, is how do we bring that together in a cohesive way that can be understood by the person configuring the network, by the person troubleshooting it. You can't have to have a PhD in all things, vendor to be able to configure the network. So simplicity is incredibly important. That's something we hear all the time from our customers. And I think that zero trust is a great example of that. So zero trust is a super interesting, important technology that many, many people want to have on their network. But the way that it was added was kind of a bolt on. So you had zero trust providers, and they bolted that onto their SD-WAN solution. And you had to choose, which traffic was going to be treated or which applications you wanted to use zero trust with. And, that had to be also resolved with the applications that were going through SD-WAN and the rules there. And it just got really complicated. And in security, and Mauricio, I think you'd agree with me or disagree, but complication to me is the enemy of security, because the more complicated it is to configure, the more likely it is you're going to make a mistake. Just human nature, or something somewhere is going to change and you're not going to change it over here, and you're going to leave a gap in your network. So our stance has been that not only is simplicity important, but important security capabilities such as zero trust need to be built in from the ground floor. They need to be inherent in the solution. And in that way, you're more likely to take advantage of it. It's more likely to be something that you can almost use by default, as opposed to having to remember to go set up. So for example, in our solution, we call it, I'm going to get it wrong, Mauricio, and I'm the marketing person. Not connect, but verify then connect. Did I get it right?
Yeah. I mean,
gestures.
really, because the whole principle of zero trust, right? You know, you mentioned the legacy of not only SD-WAN, but just in network in general, right? Was connect first, then authenticate. And zero trust really flips that around to authenticate and then connect. Like, make sure you're even authorized to be on the network before you're even allowed on the network. And even once you're in the network, then every single time you try and access something, we check to see if you're even authorized to go there. And so, yeah, I mean, because a lot of times the old way of thinking about it before zero trust was just like, oh, you got on the network, so you must be allowed to be here. So everything's open to you, you know, feel free and you know, snoop around, which created a lot of problems and still creates problems today as people are still trying to navigate how zero trust fits into their network. I mean, you still hear data breach after data breach, which is a bad thing that we just hear so many data breaches from, that they got into the network and were able to pivot to from a non critical system or an IoT system or something, and then pivot to something more critical where valuable data is stored. In fact, I just heard of one in the news just the other day where they got access to a company's SharePoint because they were able to pivot in the network.
And now they're just flush with PowerPoint decks.
Also, I feel like I should be interviewing you. Um, but yeah, I agree. So to go back to your initial, question, Taylor, I think simplicity is important, and it is in how you configure, and but it's also in making the system itself more simple. You can't just put a layer of management on it and call it simple. And I think what we tried to do by incorporating zero trust into the fundamentals of our connectivity solution, VPN solutions, and SD-WAN solutions is it's easy to take advantage of and harder than to sort of screw up.
Do you think that cohesive solution, or let's say like the zero trust foundation, is a primary consideration for what enterprises should look for when they're selecting an SD-WAN solution? Or are there other things that they should really keep in mind when they're shopping around?
I will say, with SD-WAN, like any new technology, AI, any new technology, you need to be really clear about what you want to accomplish within your network before saying zero trust should be primary. I just got out of a seminar on AI, and so many people are like, I need AI. Why? Don't ask hard questions. And I think there's a little bit of that with SD-WAN. Know what you want to accomplish with it. Know where your problems are. And it could very well be that zero trust is fundamental and important to it. In which case, you should definitely check out our solution. But it's not always the case. So understand what you want to accomplish from it. And in general, that's going to give you a better result. If you don't know what you want, if you don't know the issues you're having in your network or the applications you want to protect or what security characteristics you have, what other solutions do you have in your network, you need to understand those things before deploying SD-WAN. Otherwise, you may feel like, oh, this is supposed to be a panacea that fixes all our problems, and it didn't. Again, I'm looking at you, AI. And that's one of the things that we work with a lot on our customers in kind of a consultative conversation is, where are your issues? What are you trying to accomplish? Let's recommend the right solution, the right configuration to take advantage of that.
Speaking of everybody's favorite new buzzword, what do you think the place of AI is going to be in SD-WAN solutions going forward?
I mean, I think it's going to solve all our problems, obviously. No, I think I don't have an answer on that particularly. I've got opinions on what I think some low-hanging fruit is. Definitely configuration has always been a tricky part of SD-WAN, even as we've tried to simplify it. As they've grown, there's just a lot more going on. And so having some AI guidance would be really helpful, even if it's just more on the kind of generative AI where you sort of ask questions and it gives you answers versus heuristically determining what you're doing and making recommendations. I think that saying this is what I want to accomplish. So I want my vehicle to connect reliably across a satellite and a cellular link. If I could verbalize that, I think one of the uses of AI could be simply to help guide you in your configuration to accomplish that. So I think that's a nice low-hanging fruit. I think the next level up is really using the intelligence part of it to look at your traffic patterns. hey, it looks like, this particular site is having poor application performance because every day at 2 o'clock, some big download occurs. Maybe you should consider this. So I think that is something that we will see. It makes a lot of sense. And the benefit of SD-WAN and the growth that it's had and the breadth of it is that it does have visibility into a lot of your network, and it can make those. And then I think troubleshooting is another big one. Something's gone wrong. Why? That is a huge question that people spend a lot of time trying to drill down on. Why am I failing here? Somebody calls me up and says, this isn't working. Why? And I think AI can really help with that. A human can do it. It's just that sometimes it takes correlating information across different screens. And that's literally what AI is good for, pulling a lot of data points together and coming up with a conclusion. So I think those are a few areas where we will see it apply.
Well, I mean, I agree with the troubleshooting. You're right. All the things that you talked about a human can do, but I think everywhere, every day, across businesses, public sector, everybody's being asked to do more with less resources. So any place that those can augment, a human where you just don't have enough humans to do those things, I think that's definitely where that is going to become extremely useful in these kind of solutions.
And, one of the things that we're talking about, no commitment here, so it's just conversation, but we have a range of cellular solutions. So we've spent a lot of time today, of course, talking about our SD-WAN solutions and SASE solutions across cellular, but we also have the ability to use cellular as a private sort of LAN technology. We have the ability to bring in neutral host solutions that allow you to connect to the public network within your enterprise. And so we also want eventually to use AI to bring insights into all of the uses of cellular across the network. So where is my cellular traffic going? Am I better off using a private network or a public network? Would my network performance be better if I use cellular in this circumstances or that? Would my cost structure be better? I think one of the benefits of having a platform of solutions, AI needs data to survive, right? The more data, the better its model is. So the more you use a single vendor solution and the more you use, in our case, sort of cellular across that wide range of solutions, the better insights you'll get beyond even your SD-WAN solution. And that's something that really excites me in general in AI, is sort of bringing together things that we already know that SD-WAN has a database, but there's a lot of other databases out there. And the more you can bring that data together, the better insights and the better guidance we can get from AI.
Well, speaking of insights and guidance, I feel like that's what we've gotten from you during this conversation.
Mauricio never listens to me, but thank you.
And we've taken up a lot of your time, Donna, so I really want to thank you for joining us today to chat about SD-WAN, where it has been, where it is, a little bit about where it's going. These are important conversations that I know are going to continue to evolve. So thanks for joining us in our first stab at an SD-WAN discussion.
Thank you. It was fun. Always enjoy talking to you too.
So I enjoyed this conversation with Donna for a lot of reasons, but one of my favorite reasons is that if you've been listening to our podcasts, or at least a few over time, you can start to see how these pieces are really fitting together. One of the things that she said is simplicity equates to cohesion, right? The more in sync your applications are, the more in sync your security and SD-WAN and SASE solutions are, the easier it's going to be on your IT team. So as we think back to our podcasts that we've had and where we've covered things like Zero Trust, where we've covered things like SASE, and now we're talking about SD-WAN, you can start to see this picture come together of where the instances when they exist from a single vendor or in a single pane of glass, those are going to be the easiest to troubleshoot, to manage, to scale.
Yeah, I mean, Donna mentioned it as our industry is just, I don't rife or just full of acquisitions, right? Companies acquire each other, they merge, they, unfortunately some go out of business, others, take their place and potentially buy all their assets. And then you get this management portal or solution that kind of looks just like Frankenstein, right? It looks like just different parts of different things just bolted together, and it's not truly a unifying experience. And Donna kind of, hinted towards it is the configuration piece is the piece where it is the most susceptible to something going wrong, and then all of a sudden you have a vulnerability in your network that you don't know about.
Yeah.
And so, when you have these solutions that are kind of just pieced together from different acquisitions or mergers or partnerships, that's where it becomes really complicated, because then I have to go here to do this piece, and then here to do this piece, and then maybe in another window to do this piece, and does that relates back to this, and I don't remember how this was configured, and then all of a sudden you either have to start over from scratch, or that's, like I mentioned, where the misconfigurations and vulnerabilities pop in. So, having all of that in a unified, simple to use platform, and eventually, hopefully leveraging AI in an effective way to help just start with that intent, and then AI can guide you through, how to configure that in the most simple, easy to understand way. And then also potentially AI could be used to test it, right? So it's like, all right, I set this up in my lab environment or whatever. Now you just tell AI, hey, go make sure there's no vulnerabilities or gaps in the configuration, and then can report back to you. So having those, simple solutions that are a pane of glass right now, where it's all manual by a person, will help lead into those solutions where AI can help augment and check the person's work. Because despite what the sensationalists will tell you or the doomsayers will tell you, is AI can't take over everything, right? There's always going to have to be a human behind it to not only to check its work, but AI just can't understand the nuances that a human can, no matter how much programming or how much data is used to train it. So it's going to be a partnership at all times, but there's going to be places where AI is going to be able to, up level that human skill exponentially.
Absolutely. Well, thank you so much for listening. If you enjoyed this conversation about the evolution of SD-WAN, share it with a friend. Then rate and subscribe to What's Your Signal wherever you listen to podcasts.